Hello everyone, welcome to the channel and the series of solving previous year questions for class 10 maths. In this video, we'll be solving previous year questions for polynomials class 10th basic. We have already covered the same set of video for standard mathematics of the same chapter. Now we are covering basic mathematics. All the questions will be solving are the questions from CBSE board paper for sessions 2023-24, that is last year. I have analyzed all last year papers of CBSE, all the 5 sets as well as the compartment paper of last year, and sort out these questions for you. And this video will be very helpful for you as we are going to solve the exact question appear in the CBSE board exam. And the plus point is for you all, you can easily get the list of questions along with the detailed solution of it in this video lecture. So stay tuned till the end of the video. As per the trend of this chapter, the last year, this chapter has a weightage of 4 to 5 marks, or I could say in the basic maths, it's almost 4 marks. In each and every paper of basic maths, you could find it. This chapter covers a weightage of 4 marks with a combination of MCQs, 3 marker, or even 2 marker questions have also been seen in this from this chapter. So it's a very scoring and easy chapter for you people. So stay tuned with this video. This video will be very helpful for your board preparations. So let's begin the video with solving some MCQ type questions that are 1 mark question, multiple choice question. The first question says as if the product of the zeros of the quadratic polynomial is 5x square plus 7x plus k is 2 by 5, and we are asked to find the value of k. What is the value of k? So it is given that the product of the polynomials. So we know that what is the product of the polynomial? The product of zeros of the polynomial is c by a. And c here from the given polynomial, if we see what is c, c is k and a is 5. If you matches the value of a and c from this quadratic polynomial, and it is given that this value is equals to this, that is 2 by 5. So k by 5 is equals to 2 by 5. 5 got cancelled by 5 and value of k is equals to 2. And if we match the option, we get option number D. That is the correct answer for this question. Now, the second question. It's a very similar kind of question. So let's solve this one as well. For what value of k, the product of the zeros of polynomial, the polynomial is kx square minus 4x minus 7 is 2. So here it is given that for what value of k, the polynomial has the product of zeros as 2, means alpha beta should be equals to 2. So we know that the product of zeros of the polynomial is c by a. So if we equate the value of c and a from this quadratic equation, we got minus 7 by k. Okay. Now it is said that this value is equals to 2. So minus 7 by k equals to 2. Now, if we multiply this k in the right hand side, minus 7 is equals to 2k, and we are asked to only find the value of k. So, we'll take this 2 here in the denominator. So, we get minus 7 by 2 equals to k, and that was the question. We are asked to find the value of k. So, if we matches the option, the correct option is option number B, that is minus 7 by 2. Moving to the next question. The question number third. The question number third says that the zeros of the polynomial is 3x square plus 11x minus 4. So we are asked to find the values of the zeros of this quadratic polynomial. So this question is moreover a quadratic equation question or a polynomial question, but we are considering this question in the domain of polynomial. So let's solve it. So this is a quadratic equation, 3x square plus 11x minus 4, and we'll simply split the middle term of it and find the zeros of it. So if you don't know how to how to use the method of middle term splitting, I'll explain you here. So what we do, we took the product of a and c. So here the product of A and C is 12. Okay, and we'll split the middle term, that is B, into such a way that either the addition or subtraction will give us 11 itself, but the multiplication of those number will give us 12. So what we simply do, we just write the factors of 12. So if I want to split this quadratic polynomial, what I'll do, 1 into 12 is 12, and I can easily use this because the multiplication gives me 12 and the subtraction 12 minus 1 gives me 11. So that's perfect for this equation. So let's solve it. 6x square plus 12x minus x minus 4. Okay, now we'll take common. We can take 6x common from here, and x is left plus 4 is left. 3 into 4 is 12, and x as it is. Now we could take minus 1 common and x plus 4. So these two terms we get common. That could again be taken common from this equation, and we got 3x minus 1. So the value of x from this equation is 1 by 4, and from this is minus 4. Sorry, 1 by 3. It's 1 by 3. My bad. So these two are the zeros of the quadratic polynomial that is given to us. So if we match the option minus 4 and 1 by 3, minus 4, 1 by 3, option number C is absolutely correct. Moving next to question number 4. The question number 4 says that in the figure I'll be pasting on the screen and you can easily access it from there. The graph of the polynomial is given and we are asked to find the number of zeros of the polynomial. So we can easily see from the graph figure, or I could say figure given in the question, that the graph of the equation intersects the x-axis at two different points. So from that we could interpret that the number of zeros of the polynomial for which the graph is drawn is 2. The tip is, for this question, the number of times the graph of any polynomial intersect x-axis. For x-axis the point will be, there will be certain coordinates for x, and for y it will be 0. Okay, so that number of times it intersects the x-axis is equal to the number of zeros of polynomial. I'll give you example here. So if we know that this is a equation, or this is a graph of for a quadratic polynomial. If you don't know, I'll tell you that for a quadratic equation, the graph is formed in the graph is drawn in the form of parabola. This shape is called parabola, and this is basically called as upward parabola, and this one is downward parabola. So it intersects the x-axis at 2 points. So this proves that the number of times it intersects x-axis, that is the number of zeros. As we know that for a quadratic equation we can get at most 2 zeros, and these two are the graph for an quadratic equation. I hope you can understand this. If still you have any kind of doubt, just text in the comment section. I will definitely reply to you. Let's continue the video now with solving some 2-marker question. There were 4 2-marker question that appeared in last year board examination, and the plus point for this, these 2-marker questions were in option. Like you have the options either to solve one out of the 2. So let's solve this question. What this question says as, if alpha and beta are the zeros of the polynomial is given to us, that is 8x square plus 14x plus 3, and we are asked to find the value of 1 by alpha plus 1 by beta. So it's a very easy question. So let's solve it. We are asked to find the value of 1 by alpha plus 1 by beta. So first of all, what we'll do, we'll take the LCM this side. We'll get, if I multiply beta here, I'll get beta upon alpha beta plus alpha upon alpha beta. That could be written as alpha plus beta and alpha beta. And as our knowledge of the polynomial from this quadratic equation or this polynomial, we can easily find the separate values for alpha plus beta and alpha beta. So let's compute it. Alpha plus beta is minus b by a. We all know it. Minus b by a. So from this equation we get minus 14 by 8. Am I correct? And value of alpha beta. Alpha beta is equals to C by A. So from this equation we can interpret the value of C by A as well. C is 3 and A is again 8. And we can put these two values here in this equation. So what we'll get, alpha plus beta is minus 14 by 8 upon 3 by 8. Any kind of question, any kind of equation or problem, you find this double fraction. So what's the method to solve it? You have to take the denominator fraction as the reciprocal of it. I have written the numerator as it is, and I'll reciprocal is denominator and multiply it as it was in division. The opposite of division is multiplication. I'll got from 8 got cancelled by 8, so the value is equals to minus 14 by 3. As 14 is an even number and 3 is an odd number that cannot be further simplified, so that's the final answer, minus 14 by 3 for this question. So let's continue by solving another 2-marker question. And these two questions were in option in last year board examination basic mathematics paper. So let's solve this question. This question says that find a quadratic polynomial whose zeros are, we are given with the zeros. 0 is minus 9 and 6. So let's say alpha is minus 9 and beta is 6. So I'll tell you two methods to solve this question. Two different methods. One is a very direct method and simplified that can be used, and you can easily score 2 marks out of this, two out of two from of this question. So let's solve it. I'll tell you both the methods. Method number one. The method number one we could use uh, it as, so it is as we find the zeros of the polynomial. What we can do, this minus 9 could be written as x plus 9, and this 6 could be written as x minus 6. Am I right? And if I interpret this, I'll get minus 9, I'll get plus 6. So what we'll do, now we'll solve this equation. Got x square minus 6x plus 9x minus 9 into 6 is 54. What we'll get, x square plus 3x minus 54. Okay, this is the method number one. The method number two is very similar to it. This method says that we can remember a formula, that is x square minus alpha plus beta x plus alpha beta will give us the equation. That is a direct method. Even this was indirect method, you could say. So here we need to find alpha plus beta. Alpha plus beta is plus 3 and alpha beta is minus 54, and we'll put both of these value in this equation. We'll get x square minus this value is in negative. Okay, so minus when multiplied with minus it become positive, plus 3x minus 54. The final answer is x square plus 3x minus 54. So from both the method we got the same answer. So you can prefer whichever method it's easier to use to you. Let's continue the video by solving some more 2-marker questions from last year CBSE board paper. So the question number 7. The question 7 says as if one of the zeros 0 of the quadratic polynomial, the quadratic polynomial is 6x square plus 37x minus p minus 2 is reciprocal of other, and we are asked to find the value of p. So it is given that if we assume that the first zero of the quadratic polynomial is alpha, then the another quadratic polynomial, another zero will be, if this is the 0 1 and let's say 0 2, it is the reciprocal of other, so that could be written as 1 by alpha, and we are asked to find the value of p for this quadratic polynomial. So what can we do that, so if we take the product of these two zeros, alpha into 1 by alpha, which is equals to 1, alpha and alpha got cancelled. So we can equate the product of the polynomials from this equation to 1. So let's do it. So we know that the product of zeros of polynomial is c by a. If we write it from there, from the quadratic polynomial, we get minus p minus 2 upon 6, that is c by a. And we know that the product of our zeros of our polynomial, that is, if one zero is alpha and the other is 1 by alpha, it is equals to 1. So from here we can solve the equation now and easily find out the value of p. This 6 got in here into multiplication, and if we multiply this minus in the whole equation, we get minus p plus 2 equals to 6. And when this on solving this 2, we got minus p equals to 6 minus 2, so p is equals to minus 4. So we can easily calculate the value of p for this question. I hope you understand it. So moving next to question number 8. This question says that if alpha and beta are the zeros of the quadratic polynomial, the quadratic polynomial is given to us, that is ax square plus 7x plus 5. This is the polynomial and we are asked to find the value of alpha square plus beta square plus alpha beta. So this is I could call it a good question for basic mathematics of for this chapter from polynomials. So it's a good question, and some of you might even make mistakes in it. Many of you, what you do when it is given and it is asked to find 1 alpha square plus beta square plus alpha beta, and what you people do is, many of you will assume this alpha plus beta, this value equals to alpha plus beta whole square, which is absolutely incorrect. How? I'll tell you. So first of all, we'll simplify this equation and then we'll find the value from the quadratic polynomial and substitute on the simplified form of this equation. So first of all, to simplify this, we'll need this identity. So alpha plus beta whole square is equals to alpha square plus beta square plus 2 alpha beta. And if you take alpha square plus beta square equals to alpha plus beta whole square, you are missing this 2 alpha beta at that point, which makes your assumption absolutely incorrect. So from this case, what we are asked to find this value. Okay, so in place of alpha square plus beta square, we can replace alpha plus beta whole square minus 2 alpha beta, which is equals to alpha square plus beta square. I have just shift the value from LHS to RHS and I have easily got the value of alpha square plus beta square. Now I'll substitute this value in my equation asked in the question. So in place of alpha plus beta whole square, I can write alpha plus beta. In place of alpha square plus beta square, I can write alpha plus beta whole square minus 2 alpha beta plus alpha beta. Okay, so on further simplification, I got alpha plus beta whole square minus alpha beta, when 2 minus 2 alpha beta plus alpha beta, it will give us minus alpha beta. And these two values, as this is the sum of the zeros of quadratic polynomial, this is the product of the zeros of quadratic polynomial, and the polynomial is already given to us, so we can easily find the value of sum of the zeros of quadratic polynomials and the product of zeros of quadratic polynomial from this quadratic polynomial which is given to us. So if we want to find the sum of the quadratic polynomials, that is minus b by a, from this equation we can easily find it. So it is minus 7 by 2 whole square, as it is minus alpha beta. Alpha beta is c by a. What is the value of c? C is 5 and a is 2. Now we just need to solve it. So what is the square of 7? The square of 7 is 49 and the square of 2 is 4 minus 5 by 2. Now we'll take the LCM and solve it further. We need to multiply both in the numerator and denominator by 2 and we got this value. So that is, when we subtract 49 minus 10, we got 39 upon 4, and that this will be the final answer, as the numerator is an odd number and the denominator is an even number. So this cannot be further simplified. On solving it, you will get some decimal value out of it. that you can solve if you wish, or you can just simply leave this as your answer as well. You will get full score. So this was a tricky and a bit conceptual question. I hope you understand it. Still have any kind of doubt in this question, you can um, put your doubt in the comment section. I will definitely reply to you. So continuing the video, now we have 3 marker questions, and I have shortlisted some 10 3 marker question from last year board examination for you all. And the probability of getting a 3 marker question from this chapter is more than a 2 marker or an or a multiple choice question. So you need to give more focus on 3 marker questions. And the 3 marker questions in polynomials mathematics basic is very easy, so you can easily understand it. And even I have classified these questions as per the different domains for you, and will be solving it in. So let's begin solving question number 9. This question says, as if a quadratic polynomial, each of whose zeros, find a quadratic polynomial, each of whose zeros is respectively twice the zeros of the polynomial 2x square minus 5x plus 2. So we need to find a quadratic polynomial whose zeros are twice the zeros of this polynomial. Okay, so if the zeros of this polynomial are alpha and beta, then we have to find a quadratic polynomial whose zeros are 2 alpha and 2 beta. That we need to find out. Okay, so first of all, what we'll do, first of all we'll find the sum of zeros of this polynomial and the product of zeros of this polynomial. And then from that zeros, the sum and the product of zeros, we can twice it, the twice to the zeros, and then can easily find a new quadratic polynomial. Okay, so let's begin solving for this quadratic polynomial. It is 2x square minus 5 plus 2. If we try to find the sum of the zero, that is minus b by a, alpha plus beta is equals to minus b by a. So from here we can get 5 by 2. Okay, and the product of zeros, that is alpha beta, which is equals to c by a. So c by a is 2 upon 2. Okay, so now we are asked to find a quadratic polynomial whose zeros are twice the zeros of this polynomial. So then their sum will be 2 alpha plus 2 beta. Okay, and if I take 2 common, we'll get alpha plus beta into 2. Okay, and same if I do here, that will become 2 alpha multiplied by 2 beta. So we can take 4 common and write alpha, not 4 common, we are not taking common, we have just separated 4, and write alpha beta together. So we have already found out the value of alpha plus beta and alpha beta, and that can be substituted here. On simplifying this value of alpha beta, we got 1. So if I substitute these two values in here, if 2 we have taken common, I'll write 5 by 2, and 2 get cancelled by 2. So the sum of the zeros of the polynomial we are asked to find is 5. And if I put alpha beta into this, that is 4, 4 into 1 is 4, then their product is 4 and the sum is 5. So we know the now need this formula, that is x square minus alpha plus beta x plus alpha beta, and from this we can easily find out the quadratic equation. So we'll substitute the value as it is, x square minus alpha beta. The value of alpha plus beta is 5, minus 5x plus the value of alpha beta is 4. So what we got is x square minus 5x plus 4. That is our new quadratic equation that we are asked to find in this question. So this is our next question, and it is also a very good question as per if I talk about basic mathematics, so this question says as if one zero of the polynomial is given to us, that is x square minus 6x plus b is twice the other. If one zero is twice the other, and we are asked to find the value of b, also find the zeros of the polynomial obtained. Okay, so what we need to do, first we need to find the value of b, and then on substituting this value of b, we are asked to find the two zeros of this polynomial. So if one zero, let assume the one zero of the polynomial is alpha, and it is said that the another one is twice of that, so that will be 2 alpha. Okay, so alpha plus 2 alpha is equals to minus b by a, that is the sum of the zeros of polynomial. So if we substitute the value of minus b by a from this equation, so one thing that you need to remember, don't assume this b with the b of the standard form of quadratic equation. Okay, I'm writing the standard form of quadratic equation, that is a x square plus bx plus c. So here this b is equals to c. Don't assume the b, this b to this b, that they both are entirely different. From this quadratic polynomial, the value of b is minus 6, not this b. Okay, so the sum of the zeros of polynomial from this quadratic polynomial, we get 6 as minus 6, as it was minus 6, the minus minus got multiplied and become 1, and value of a is 1. So 3 alpha is equals to 6, or I could write alpha plus 2 alpha is 6 simply. Okay, now talking about the product, so alpha into 2 alpha will be equals to c by a, that is equals to b. Okay, so it become 2 alpha square, which is equals to b. Okay, and we can easily find the value of alpha from this equation. Okay, I have written 3 alpha is equals to 6. If I took this 3 into division, I got alpha is equals to 2, and if I substitute this alpha here in the this equation, I can easily get the value of b. So 2 into 2 square, so it will become basically 2 cube, that is 2 into 2 into 2. So 2 into 2 is 4, 4 into 2 is 8. I got value of b as 8. Now the second step of this question, which is we need to find the zeros of the polynomial obtained. So we'll substitute first of all this value of b in this equation, what we got as 8. So our polynomial that was given in the question, it becomes this, that is x square minus 6x plus 8. And now we need to find the zeros of this polynomial. So how could we find the zeros of the polynomial? There are two methods. Either you could use quadratic formula, or then you could split the middle term as per your syllabus. So I'm going to splitting the middle term in the method of middle term splitting. What we need to do, we need to take the product of these two, that is a and c. Okay, here the product is 8, as the value of a here is 1, and we need to split this b somehow that the product is 8, but the either the addition or subtraction will give us the same value. So I'm splitting it as 4 into 2 is 8, on subtracting on minus 4x minus 2x, I again get minus 6 back. So that's how I have split this value. If I take x common, I got x minus 4, and from here if I take minus 2 common, I get x minus again 4, and I could again take common from this equation, that is x minus 4 and x minus 2. Now the zeros of this quadratic polynomial become x equals to 4 and x equals to 2. That's was this question, that is the solution for this question. I hope you understand it. So what we did, I'll give you a quick recap for this question. We have done lots of steps in it, you might get confused. So this was the polynomial, and we are asked to find the value of b, and on finding the value of b, we are asked to also find the zeros of the polynomial, and the condition was given as one zero of this polynomial is twice the other. So first of all, we took the one zero as alpha and we make it twice, that is 2 alpha, and then on substituting the value of minus b by a equals to sum of 0, we have find that the value of alpha, and on taking the product of it, he, we can find the value of b, and we have put the value of alpha from here, which we got here, into this equation, and find out the value of b. As soon we find out the value of b, we have substituted the value of b in this equation, and then by middle term splitting we have find the zeros for our quadratic polynomial. I hope you understand it. Moving to another 3 marker question. So this question says as zeros of the quadratic polynomial, that is x square minus 3x plus 2 are alpha and beta, and we are asked to construct a quadratic polynomial whose zeros are 2 alpha plus 1 and 2 beta plus 1. So first of all, we need to find the value of alpha and beta, so that we could find these two zeros as 2 alpha plus 1 and 2 beta plus 1. So what we'll do, first of all, we'll find the zeros of this polynomial, then we'll find the value of 2 alpha plus 1 and 2 beta plus 1, and then we'll use the formula and find formula to substitute the sum of the zeros and product of zeros, and we'll find out a quadratic equation. So let's begin it. So first of all, I'll split the middle term of this quadratic polynomial and find out the value of alpha and beta. So that can be done as, so on product of these two we got 2, as here the value of a is 1. On factorizing 2, I got 2 into 1, which is equals to 2, and on adding it, I got 3. So x square minus 2x minus x plus 1, that it could be written as this. So if I take x common, x minus 2, and here minus 1, if I take common, that is x minus 2. How I have taken minus 1 common? If I multiply this minus into the bracket, I got again addition here. Okay, again I could take my x minus 2 common, and the another one is x minus 1. So from this I got the value of two zeros as 2 and 1. Okay, I'll take alpha as 2 and beta as 1. So now the second step is I'll find the value of 2 alpha plus 1 and 2 beta plus 1. So 2 alpha plus 1, and what is the value of alpha? The value of alpha is 2. 2 into 2 plus 1, which is equals to 5. So my alpha dash, I write alpha dash are equals to 5. The another one is 2 beta plus 1. 2, what is the value of beta? We have find the value of beta as 1. 2 into 1 plus 1, that is equals to 3, which is equals to my beta dash. Okay, now we'll find the sum of the zeros. Now sum of alpha dash plus beta dash and product of alpha dash and beta dash. So sum of alpha dash plus beta dash, that is 5 plus 3 is 8, and 5 into 3 is 15. Okay, you can easily understand till here. Now we'll use this formula, that is x square minus alpha plus beta x plus alpha beta, and I'll substitute this alpha plus beta with my alpha dash plus beta dash, and this alpha beta with alpha dash into beta dash, and I can get x square minus 8x plus 15, and that's it. We have done with the question. That was what we were asked to find out. We were asked to find out a quadratic polynomial whose zeros are 2 alpha plus beta and uh, 2 beta plus alpha, where alpha and beta are the zeros of this polynomial. So what we did, first of all, we split the middle terms and find the value of alpha beta, which are the zeros of this polynomial, that is x square minus 3x plus 2. Then we found out the value of 2 alpha plus 1 and 2 beta plus 1. From here we have found out a value of both of these, and then we on this was the step 1. I could give it as step 1, this is step 2, this is step 3. In third step, we find the value of the zeros, the sum of the zeros and the product of zeros, and then simply substitute this in this formula, and we got out the quadratic polynomial. I hope you understand it. Let's continue with solving another 3-marker question. Question number 12. The question says as if the zeros of quadratic polynomial x square plus x minus 6 are alpha and beta, and we are asked to construct a quadratic polynomial whose zeros are 1 by alpha and 1 by beta. And this is a very similar kind of question we have solved just now. In that, we were given to find a polynomial whose zeros were 2 alpha plus 1 and 2 beta plus 1. Here we are asked to find a polynomial whose zeros are 1 by alpha and 1 by beta. So simply we'll follow the same step. But there are two methods that from which this question could be solved, and I'm going to tell you the simplest one. Okay, so let's begin solving it. First of all, we'll write this quadratic polynomial. Okay, I'll tell you both the methods. Let's say it as method number 1. So in this method, what we'll do, we'll find the value of alpha plus beta, that are the zeros of this polynomial. So alpha and beta will be minus 1. From this, as alpha plus beta is equals to minus b by a, and alpha beta, that is c by a, will be equals to minus 6. Fine. Now what we need to construct a polynomial that is sum of zeros and product of zeros, this beta. Okay, if I took LCM, it will become beta plus alpha beta upon alpha, that could be written as alpha plus beta upon alpha beta. Okay, if I substitute the value minus 1 by, from here, the value of alpha plus beta and alpha beta, from here I could cancel out minus and minus, I get 1 by 6, and the value of alpha into beta, that could be written as 1 upon alpha beta, so that could be written as 1 upon minus 6. Okay, and I can substitute the value of alpha plus beta and alpha beta. So alpha plus beta, my alpha plus beta here is 1 upon alpha plus 1 upon beta, and my alpha beta is 1 upon alpha into 1 upon beta. So that could be written as x square minus alpha plus beta x plus alpha beta, so x square. My alpha plus beta, which is equals to this, can written 1 by 6x minus 1 upon 6. You can further simplify it by taking the LCM at 6. That will be written as 6x square minus x minus 1 equals to 0. I hope you understand this method. Let's solve this question by another method as well. Another method of solving is same as we have solved the previous question. Okay, what we'll do, we'll split the middle term and find the two zeros, that is alpha and beta of this, and then from these alpha and beta we'll find the value of sum of our new zeros, that is 1 upon alpha and 1 upon beta. So I'll show you that as well. Okay, on splitting the middle term, this 6 could be split as 2 into 3. 2 into 3 is 6, so plus 3x minus 2x, and on the plus 3x minus 2x will become positive x common. From here I could take minus 2 common. Now again I could take minus x plus 3 common and x minus 2 common. Now the two zeros, my alpha is minus 3 and my beta is plus 2. You can even interchanges, there is no problem. You could take alpha as 2 and beta as minus 3. Your answer will be same. Now I'll find 1 upon 1 plus the sum of the zeros, 1 upon alpha plus 1 1 upon beta. Again I'll need to take the LCM, will be alpha plus beta upon alpha beta, and the product of these two, that will be equal to 1 upon alpha into beta. So alpha beta, that could be written as minus 3 upon minus 3 plus 2 and minus 3 into plus 2. Here 1 upon minus 3 into 2. So this value will be minus 1 upon minus 6, minus minus got cancelled, will be equal to 1 by 6. This value will be equal to minus 1 by 6. Now these two values could be substituted the same way we have done here. I'll again tell you, x square minus alpha plus beta x plus alpha beta, x square minus alpha plus beta 1 by 6 plus alpha beta will be minus 1 by 6. It could be written as 6x square minus x plus minus 1. This is a minus equals to 0. So there were two different methods of solving this question. I hope you understand both of the methods, and you could solve it by whichever method you feel much easier and to which you are more comfortable. On solving both the methods, you will get a full score on this question in the board examination. I hope you understand it. And this were the two in these what we have solved the two questions of the same domain. The next five questions will be solving off of will be of similar domain, of similar type, I could say. So this is the next question, and now the rest five questions, the last five questions for this video will be of this type only. And this type of question, finding zeros of polynomial and verifying the relationship, is a very easy type of question in very scoring. You just need to find zeros from this polynomial and verify it with the relationship of sum of zeros equals to minus b by a and product of zeros is c by a, and you can easily score a you can easily get full marks in these type of question, as they are very easy, very less time taking, and you don't need to put any extra knowledge to solve these type of questions. So let's begin solving it. This question says as, find the zeros of the quadratic polynomial. The polynomial is given to us as 4x square minus 4x plus 1, and we are asked to verify the relationship between the zeros and the coefficient. So this is a two-step question. The step 1 will find the zeros of this quadratic polynomial, and step 2 will verify the relationship. Okay, so let's begin solving it. 4x square minus 4x plus 1. Again, we'll find the 0 by middle term splitting. 4x square minus 2x plus 1. This is how we could split minus 4, as the product is again 4, and on subtracting, on adding it, we got minus 4. I'll took 2x common, and I can get 2x minus 1. Again, I'll take minus 1 common, 2x minus 1. From this, I can take 2x minus 1 common and 2x minus 1 common. So now my alpha is also 1 by 2 and my beta is also 1 by 2. That means we have the same zeros for this quadratic polynomial. This was the step 1. The step 2 is, now we need to verify it. So what we'll do for the verification, alpha plus beta should be equals to minus b by a. Okay, now we need to find this alpha plus beta by actual adding these two. By so 1 by 2 plus 1 by 2, I'll get 2 by 2, which will be equals to 1. Now if I take the value of minus b by a from this polynomial, the value of b is minus 4. When we multiply minus 4 upon 4, this minus got multiplied with minus b, become plus, and 4 upon 4 gives us 1. And this relationship as LHS is equal to RHS, it's been verified. Okay, now we need to also verify the product of zeros of the polynomial. Okay, that will be alpha beta. So alpha is 1 by 2 and beta is again 1 by 2, which should equal to c by a. The actual multiplication is 1 by 4. Now if I take the value of c by a, c is 1 and a is 4, and hence it is again equal to LHS, it's equal to RHS, hence this is also being verified. Hence the question is verified, and that's all we need to do in this question. That's it, and you can easily solve it in 2 to 3 minutes. Okay, what we need to do, first we need to find the zeros of the quadratic polynomial. There are two methods. Either you could go with middle term splitting or by quadratic formula, then you just need to verify it by actual adding and multiplying the zeros with the relationship of sum of zeros equals to minus b by a and product of zeros equals to c by a. Moving to another question that is of similar kind. The question says, and find the zeros of the polynomial 2x square plus 3x minus 2 and verify the relationship between the zeros and coefficient. So let's solve it. 2x square plus 3x minus 2. We can split the middle term. The product of a into c is 4. Okay, so that could be split as 4 into 1. 2x square plus 4x minus x plus 2. If I took 2x common, I can get x plus 2, and minus 1 common here, I can again get x plus 2. X plus 2 could again be taken as common, and 2x minus 1 common from this side. So x is equals to minus 2 and x is equals to 1 by 2. This could be taken as alpha and this could be taken as beta. Okay, now we need to verify it. So I'll take sum of zeros alpha plus beta minus 2 plus 1 by 2 minus 4 plus 1 upon 2, which is equals to minus 3 upon 2, and this value should be equals to minus b by a. And if I take b from the polynomial given to us, the value of b is 3, and if I put it as minus b, it will become minus 3 upon 2. So this LHS is equals to RHS, hence it is verified. The similar can be done with as product of zeros. Minus 2 into 1 by 2. 2 got cancelled by 2 and we got minus 1. And this value should be equals to c by a. If I put the value from there, from the quadratic polynomial, I got c as minus 2 and a as 2. So on cancelling it, I got minus 1. So minus 1 is equals to minus 1. LHS is equals to RHS, hence this also being verified. So this type of questions are very easy and you can easily solve it. So let's solve two or three more questions of the similar type. So question number 16, it says as find the zeros of the quadratic polynomial. The quadratic polynomial is 5x square plus 3x minus 2 and verify the relationship between the zeros and the coefficient of it. So first of all, we'll find the zeros of the polynomial. 5x square plus 3x minus 2. The middle term, the product of a and c is 10. This could be split as the factor of 10 as this could be split in the similar way, 5 into 2, and we could get 3. 5x square plus 5x minus 2x minus 2. From here I could take common 5x, x plus 1. I'll take minus 1 common, and okay, I can take minus 2 common. My x plus 1, again I could take x plus 1 common, and 5x minus 2 from here. The value of x is minus 1 and the value of x is 1 by 2. So this is our alpha, this is our beta. So now the next step is we'll verify it by alpha plus beta. So alpha is minus 1 plus 2 by 5 should be minus 5 plus 2 upon 5, which is equals to minus 3 by 5. So if I need to verify it with minus b by a, so if I find the value of b and a from this quadratic polynomial, I get b as minus 3 and a as 1. So this LHS is equals to RHS, and our relationship is being verified. If I similar proceed with product of zeros, alpha into beta, so minus 1 into 2 by 5, which is equals to minus 2 by 5, and this product should be equals to c by a. If I take the value of c and a from the quadratic polynomial, I get minus 2 upon 5. This value is equals to this, hence LHS is equals to RHS, and hence it is verified. I hope you understand it. So this will be the last question. We are going to solve it. We are left with two more questions that I will be pasting the a screenshot of it on the screen, and from there you could access the question and solve it, and just comment the answer in the comment section. So let's begin solving this question. This question says as, find the zeros of the quadratic polynomial. The quadratic polynomial is given to us, that is 6x square minus 7x minus 3. And again we need to verify the relationship between the zeros and the coefficient of the polynomial. So we'll follow the same step, 6x square minus 7x minus 3. So what we need to get, we need to find 18. We get 18. So we need to split 18 somehow. We get 7. So this could be split as 9 into 2 equals to 18. 6x square minus 9x plus 2x minus 3. I could take 3 common from 3x common. I get 2x minus 3. I could get take plus 1 common. Again I can get 2x minus 3. From this I could take 2x minus 3 common and 3x plus 1 common. So my x is equals to 3 by 2 and another is equals to minus 1 by 3. My alpha is 3 by 2 and my beta is 1 by minus 1 by 3. Now I have verified its relation, alpha plus beta. So 3 by 2 minus as plus into minus will become a negative in minus 1 by 3. So on taking LCM, we need to multiply this value with 3 and this value with 2. I got 3 into 3 9 minus 2 into 1 is 2, 3 into 2 is 6. I get 8 7 by 6. Okay, so if I verify, this should be equals to minus b by a, and I know the value of b here is minus 7 and value of a is 6. On this minus into minus will become a positive and I get 7 by 6. Both of these two values are similar, hence LHS is equals to RHS and my relation is being verified. Okay, moving next with product, alpha into beta, that is 3 by 2 into 1 minus 1 by 3. This 3 got cancelled by 3 and we got minus 1 by 2. Okay, and this value should be equals to c by a. If I substitute the value of c and a from this equation, I got value of c is minus 3 and value of a is 6. On simplification, on simplifying it, 3 ones are 3, it's a 6. I got minus 1. This value is equals to this, and LHS is equals to RHS, hence it is verified. So I'm adding the screenshot of two more questions of same kind on the screen, and you can access the question from there. And these two are also the previous year questions that appear in the board examination last year. I hope this video is very helpful for you, as we have solved the actual questions of board examination 2023, and you have all the list of the question as well as the detailed solution of it. For any suggestion or in case you have any doubt, just left your comment in the comment section. I will definitely reply to you, and thank you as you have stayed tuned till the end of the video.